Okay, so here we are solving cotangent of x times cosine squared of x equals 2 cotangent of x. Now this is not a verify problem. This is an actual solve problem. So this is an equation where it says, hey, here's an equation. We need to solve for x. And remember that x is the input into our trig function, so we're looking for angles. Our first step is to set the equation equal to 0. So set the equation equal to 0. I'm going to do that first. So off to the side here, my first step, cotangent of x times cosine squared of x minus 2 cotangent of x equals 0. So I just subtracted 2 cotangent of x from both sides. Second step is factor. And the reason we want to factor is because we can use that zero product property. So I'll show you what I mean in a minute. Let's factor this. Both terms have a cotangent of x in common, so I'm going to factor that out. So I've got cotangent of x times cosine squared of x minus 2 equals 0. And now I have one term connected by multiplication. This is all one term connected by multiplication. And I'm going to use the zero product property. So step 3, the zero product property. We learned this way back when we learned our multiplication tables. The zero product property says if you multiply factors together and the product is 0, then one of those factors has to be 0. So either A has to equal 0 or B has to equal 0. Either one of those values, whether A was equal to 0 or B is equal to 0, that's going to make the product equal to 0. So that's what we're looking for here, is we're saying, okay, well, the only way to get this equation equal, this product equal to 0 and satisfy this equation is if we say, well, let cotangent of x equal to 0, or cosine squared of x minus 2 equals 0. And we're going to solve both of these equations. The cotangent of x is equal to 0. Got to dig back into that unit circle. Cotangent is x over y. The only way we can get a fraction, remember x over y, is if the numerator is 0 and the denominator is not 0. Well, the ordered pair that starts off with a 0 is either 0, 1 or 0, negative 1, right? But what's the period for cotangent? Well, the period for cotangent is pi. So 0, 1 is pi over 2. 0, negative 1 is 3 pi over 2. Here, x is going to equal pi over 2 plus n pi. When I add pi to pi over 2, here's pi over 2. When I add pi to pi over 2, I'm going to get 3 pi over 2. And then when I add pi, I end up on the positive y-axis. When I add pi again, I get on the negative y-axis, and so on and so forth. So there's one solution that's going to work. The standard period, oh, I have to write standard. The standard period though for cosine is 2 pi. So we're going to solve this equation. Cosine squared of x equals 2. We're going to square root both sides. Cosine of x equals plus or minus the square root of 2. The square root of 2. I don't square root of 2 over 1. Square root of 2 over 1. Well, that's not a cosine. Square root of 2 over 1. The square root of 2 is about 1.4-ish. 1.4-ish. This is where you want to know your flashcards. So if you took a break from your flashcards, you need to break those bad boys out and you need to look at them again. Your flashcards are critical here. This right here, the cosine of x equaling square root of 2, is not possible. Not possible. The reason being is the range for cosine is -1 to +1, and the square root of 2 is outside of that range. Think about your graph. Cosine goes as high as +1, as low as -1. Starts at the max, ends at the max, halfway between it's at the min, right? This is our graph. It goes as high as +1, as low as -1. Square root of 2 is up here. Cosine of x will never get above a value of +1. Not happening. Not possible. Therefore, no answers are generated from this factor. So our only answer is the one that we got from cotangent of x, which is pi over 2 plus n pi. Hopefully you're realizing that, oh, it's going to be so important for me to check my answers as I go. Yes, it's going to be critical for you to check your answers as you go. It's also going to be important for you to be patient with yourself. You need to try something. So you need to go back to the steps in the previous lesson and remember those 5 steps. And the 5th step was do something. Try something, because roads that lead you astray will offer you insights on how to get to where you really need to be, or it's going to provide you insights on a different problem. So for instance, right here, hopefully you got that practice in those previous lessons. 2 sine squared of x minus sine of x minus 1. This is a trinomial. What we're going to do here is we're going to factor this. So we'll factor. It's already set equal to 0. Now we try to factor. So how do we get back to 2 sine squared of x? Well, that comes from the first terms. So 2 sine of x times sine of x is going to give us 2 sine squared of x. And how do we get back to -1? Well, we're going to have a +1 and a -1. We want the outer and the inner, to be a negative sign. So we know that these are both going to be not a positive one. We know that both of them are going to be a 1. One of them will be positive, one will be negative. So we're going to get a 2 sine of x and we're going to get a sine of x. One of those is going to be positive, one of them is going to be negative. We want the result to be a negative sine of x. So we're going to have 2 sine of x plus 1 times sine of x minus 1 to give us the result that we want. Now we can take each variable factor. I'm going to start saying that. Each variable factor. So here are 2 variable factors. I'm going to set each one of them equal to 0. So 2 sine of x plus 1 equals 0, and sine of x minus 1 equals 0. So I've got sine of x equals -1/2, and sine of x equals +1. Well, where is the sine of x -1/2? Well, that's at a pi over 6 angle in quadrants 3 and 4. Well, quadrants 3 and 4 do not make a straight line with one another. So we're going to end up adding 2 pi to both of those answers. The pi over 6 in quadrant 3 is 7 pi over 6, and the pi over 6 in quadrant 4 is 11 pi over 6. So x equals 7 pi over 6 plus 2n pi. X equals 11 pi over 6 plus 2n pi. Now, where is the sine function equal to 1? The sine function is equal to 1 when the y value is 1. Well, that y value is 1 happens when the x value is 0 on the unit circle, which would be pi over 2. So in this case, x is equal to pi over 2 plus the period for sine is 2n pi. The reason we cannot shortcut this is because we want the sign to have a positive, right? A positive one, not a negative one. So we can't have the output of negative 1. We want that output to be positive 1. So we're talking about pi over 2 and only pi over 2. So we're going to add 2n pi. So here's our answers. Our answers are those 3 values right there. So you can see where we're going with this with the multiple angles. We'll get into that in the next lesson. We're also going to, I'm going to make sure that the problems that you're solving are all solutions. I think that's what it's going to say in your homework. It's going to say solve for all solutions. These are solving for all solutions, and that's what the 2n pi meant. So this means all solutions. So not in a reduced domain. All solutions. Here, this is all solutions, which includes an infinite number of solutions. You know, that's why we've got that n in there. And n stands for any integer. So that concludes the first part of 5.3. We'll get some practice with that, and then we'll move on to multiple angles. Multiple angles, after you get the practice with this, multiple angles really isn't too bad. A little bit more challenging, but you know, just a little bit more to think about. But once you have the practice down, it's just like taking an extra step. So you should feel comfortable with that. So we'll see you in the